Hi everyone. So what we're going to go over today is homework 3 since we're not going to be able to do this in class because we have reading week. So I figured I might as well show how to do this so everyone can kind of see what we're doing and how to kind of tackle this kind of problem. So most of the things we've done so far is not too, all of this is whatever, right? The story, we don't mind too much about it. Here's the kind of big part that we're going to be looking into. Question 1. Which there was two parts. The reason why I broke it up this way is because last time there was a little bit of confusion as to what the probability was. So hopefully this helped split things up a little more. But in reality, it's just kind of one question. So let's kind of go through this problem and see how to do something like this. So first things first, let's see what to highlight. So we're told there are 93 total jury members. 30 of which are members of a secret organization. And everyone else is not a member of the secret organization. So basically this is telling me that I have like my numbers of everything, right? And each jury member is given a number. So I know there's 93, so there's 1 through 93 in essence. You can choose what your numbers are, it doesn't really matter. And 5 numbers are picked without replacement. So in other words, they choose someone, they choose a second person, they choose a third person, a fourth person, and a fifth person, right? So we're not replacing it because it doesn't make sense to replace it when you're picking jury members. You can't have less than 5, so you're just gonna have to keep going till you get 5, right? So the first thing we're gonna ask is what is the probability that exactly 4 of the 5 are members of the secret society? So at this point, the biggest hint that you saw was this word, oops, why did this happen, is the word without replacement. So this should have made you flip through the notes and gone, oh, what's that formula for without replacement? And that's basically what we have. So the formula in the book basically gives me something like this. And obviously writing this on a homework is not going to be sufficient, so we need to actually write what these things are. So we are told n is equal to 93, so total jury members. And then we're told R, big R, is 30, which is our subset that are the secret organization, right? Total members of secret organization. Okay, the other things that are left is little n and small n. And these were told in problem 1, right? We're told we want to know 4 out of 5. So we know little n is 5 because picked 5 jurors. And R is equal to 4. Because we want to know picked 4 members of secret organization. So this is basically how we're coming up with these variables. So we want to know the probability, that 4 out of 5, 4 members out of 5 are 4 jurors out of 5 are members of secret organization. So what is this equal to? This is just formula of sampling without replacement. Without replacement, which is given by kind of this one here, right? So here what we have is R choose R, n minus R choose n minus R, divided by n choose n. So here at this point, we just need to plug in our values. So we get 30, choose 4, times 93 minus 30, and 5 minus 4, divided by 93, choose 5. There's also another formula for this if you want. So a second formula, this is equal to, what it is? It's n, choose r, and either of these would have been okay if you want to use the orderings instead. So this is the second formula. So this would have been okay too. It doesn't really matter too much. And so we have this. And if you calculate this, what you end up getting is roughly 0.03322. That's good enough, I guess. So yeah. So here, normally I would recommend showing work. For me, I'm not going to because just saving time, kind of go over everything. But this is our probability, the probability of 4 out of 5. Okay, so that's number 1. Let's look at part 2. So what's part 2 is asking? Part 2 is asking is use the Poisson approximation. So I know what I should be using. If you don't use Poisson at this point, you hope maybe the TA gave you 0 points. So this part was worth 5 points, by the way. This was worth 5 points. So we want to approximate. So let me go up. Let me first highlight this part because this is important. I want to use Poisson. And I want to know approximate the probability that 3 or more of the 11 days will be days where exactly 4 out of 5 of the members, I guess I should highlight all this, are members of the secret society. We're assuming each day is independent and that all 93 members are reset at the start of each day. So what this is basically telling me is I'm allowed to use Poisson. This little part here is telling me, tells me I'm allowed to use Poisson. Because remember, for a Poisson distribution to work, we should always have the same probability every single time we do a trial. If the probability changes, then we can't have a Poisson distribution. Well, we can't use the Poisson approximation, sorry. We won't have the binomial distribution. So in this case, what do we have to calculate? So the big thing here is trying to figure out 3 or more out of the 11 days. So first let me say, we'll say, oh, I need more space. No, space. Let's add a 1 here. Give me a 1. 1. And so what we're going to want to do is kind of calculate where this is coming from. So let's, I guess we'll say D, be 11, be the number of days. And what we want to calculate is 3 or more. So I want probability that 3 or more days, and then you kind of want to copy this, will be days with 4 out of 5 being members, etc. Or something to that extent. You need to kind of tell me what this event is, right? So 3 or more days is basically, how do we calculate this? Well, obviously I don't want to calculate every single day. That's a lot of them. There's 11 of them. So instead we're going to do this backwards, right? We'll take off the probability of 0, right? So this is 0 days. This is 1 day. This is 2 days. And that's it. Right? Because here we have 3. So the complement would be less than 3. So this is greater than or equal to 3. Therefore here we should have less than 3. Right? So let's calculate this, and this we're using the Poisson distribution for, right? So here I need 1 minus mu, e to the minus mu, sorry. E to the minus mu, and then mu to the 0 over 0 factorial, minus e to the minus mu, mu to the 1 over 1 factorial, minus e to the minus mu, mu squared over 2 factorial. So now we need to calculate mu. What is mu? Mu is equal to n times p, normally, which in our case is equal to d times the probability of the above, 4 out of 5. Of 5, right? This is how we wrote our probability, 4 out of 5. So in other words, I have d is equal to 11. 11 times my probability. So in other words, 0.03322. So this is going to give me 0.36543 in essence. So remember, in your calculators, you really want to keep as many digits as possible. So even if there's more, try to keep as many digits as possible, because when you start truncating, you're going to get truncation errors, and you don't want to run into that problem. So from here, we have my mu, and so I just plug in basically everywhere. E to the, well, let me make this a little easier. So mu to the 0 is 1, 0 factorial is 1. So I'll make this, mu to the 1 is mu, 1 factorial is mu, so I'll just multiply by mu, and then minus mu times mu squared over 2. And so here you just plug in, and what I ended up doing is getting these numbers. I'll show one step, 6939, minus 0.253, we'll round here for 6, 0.0463. Obviously, my calculator, I have all these extra digits, and then I end up with 0.006199112. And that's it. We're done. So the problem took roughly 10 to 11 minutes. So yeah, so hopefully that was nice and easy, better than last time. That's the hope. And yeah, that's it. Have a good day. Hope you're enjoying reading week, and I'll see you next week. Bye.